Hello, in this video we're going to talk about finding the local maximum and the local minimum of some function f of x. Now, we're going to do a specific example in a minute, but I'm just going to pretend I have any function f of x equals some expression about x. Now, there's two big steps. The first one is I need to find the stationary points. Now, all the stationary points are the points where there is either a maximum or a minimum. Now, once I find the stationary points, all I can say is there is either a max or a minimum there, and there is either a max or a minimum at that stationary point. I can't say which is which, and that's the next step. Figure out which is which, or classify them. So the first big step to find the stationary points, what we do here is we find f dash of x. What does that mean? Well, we know f of x, so to find f dash of x, differentiate it. Find f dash of x, let it equal to 0, and solve that equation. So what we will have f dash of x equals something, you work that out and put it in there, and say straight after equals 0. Now, and solve that there. Now, what do I mean solve that there? Well, it depends what you have. So the easiest case would be a nice simple equation like that there. You can solve that directly. Take the 5 across. 3x equals minus 5 and divide by 3. X equals minus 5 over 3. Another equation you might get is just a quadratic, an x squared term. Then in that case, use the minus b formula. So what will happen, you might get one answer, or you might get a couple of answers. If you use the minus b formula, you'll get two answers. So what these points are, they are the stationary points. Now again, all you can say at this stage is there is either a max or a minimum at n1, and there is either a max or a minimum at n2. I don't know which is which. And that's the next big step. Classify them. Figure out which is which. So in this step we need to find f dash dash of x. Now how do I find that? Remember, I found f dash of x in the last step. So to find f dash dash, I differentiate f dash. So find f dash dash of x and sub in each of those little n, those stationary points that I called n1 and n2 in the last step, sub each of those in one by one. Every time into f dash dash, sub each of the stationary points into f dash dash. Every time, if the answer is positive, then it means there is a minimum at that stationary point, and if the answer is negative, it means there is a maximum at that stationary point. Now, I've a funny little saying to help me remember positive min, negative max. So as I said, we need to go through, get all the stationary points, and one by one sub them into f dash dash. So pretend we sub in n1 and we sub it into f dash dash and pretend we get it to be positive. Now, I don't care what I get, the exact number I get when I sub it into f dash dash. Just throw it into the calculator. All I want to know is it positive or negative. So pretend in this case I got it to be positive. Then I have this little saying, positive happy smile. And what it means is that if you drew the function f out, it would literally be smiling at n1. So you'll look at the picture and say to yourself, would that be a maximum or would it be a minimum? Well, the bottom of the smile that must be the minimum. So there is a minimum at n1. Next, go to the next stationary point, n2. Pretend you sub in that into f dash dash. Again, I don't care what it is, just sub it in with the calculator, and you pretend you got it to be negative. Then another little saying is negative sad frown. If you drew the function out, then, and even for yourself, draw a little frown on the page and look at the frown and say, what kind of point would that be? It must be a maximum there at the tip of the frown. So there is a maximum at n2. So you need to be clear about this, because there's a problem about where the minimum is at and what the minimum is. So what this says is there is a minimum at n1, but I know a formula for f of x. And I know the minimum happens at x equal to n1. So how would I find the actual minimum then? You would sub that n1, that stationary point n1, into the function f, and you'll say the minimum is f of n1. What does that mean? It's f of n1 means that's the little answer you'll get. Get your calculator, sub n1 into f, and that answer, that means that is the minimum. And then another thing they could ask for is the coordinate of the minimum. Then the coordinate would be the x value and the y value. The x value is the n1, and the y value is what you get when you sub in n1 and f. So again, be clear where the minimum is at and what the minimum is. And it's exact same for n2. The maximum is at n2, the maximum is f of n2. That's what you get when you sub n2 into f. And if they ask for the coordinate, it would be n2 f of n2. Okay, let's look at an example question. So pretend we're asked find the local maximum and minimum coordinates of the function f of x equal to that there, 4x cubed minus x squared minus 2x plus 9. Okay, so let's go over to a blank sheet here. So what do I have? I had f of x equals 4x cubed minus x squared minus 2x plus 9. Okay, so what was my big step one? Remember, it was to find the stationary points. That was find f dash of x, and let it equal 0. Okay, so what do we have? There's f of x, so f dash of x equals, take the 3 down, but there's a 4 there to meet it, so that's a 12, and take 1 off the power, x squared. Take the 2 down here, but there's a minus there to meet it, so I'll be left with minus 2, and take 1 from that power, and it'll be x up to the power of 1, but I usually just write that as x. And for that term there, that's just I'm left with minus 2. Let that equal to 0, and solve that equation. Now, what kind of equation is that there? That's a quadratic. So straight away, I can hop into the minus b formula. So I'm going to write down my values of a, b and c. So I have a equals 12, b equals minus 2, and c equals minus 2. Okay, so I don't want to spend an hour doing the minus b formula. I don't want to write out one full scat page of 10 lines of doing the minus b formula. I want to wrap it up as quick as I can. And I showed there is another video showing how to use the calculator, some tips on how to use the calculator, and I do the minus b formula there. So if you wanted to watch what I'm going to do now, what I'm going to do now, I spent a couple of minutes in that video explaining how you do that. So if you want to check that video out, if you're having trouble wondering what I'm about to do here. So I want to get the minus b formula done in about 2 lines at the maximum. So what I do first, I write out the minus b formula. So what's the minus b formula? X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. The next thing I do, I rewrite that there, but I replace all the letters by just a set of empty brackets. Okay, why I do all this, you'll see it in a minute. What I'm going to do. It's mistake proof. As long as I type everything I need into the calculator correctly, he's going to do everything for me. So replace all the letters just by empty brackets, and the next thing I'm going to do, I'm going to sub in, put all the numbers into the brackets. So b was minus 2, again minus 2 for the b, a and c, a is 12, c was minus 2, and on the bottom a was 12. Okay. Now I'm going to wrap this up. How I wrap this up now, what I do first is, see the square root term, I throw all of that, type all of that exactly as I see it into the calculator and write the little answer up there. So let's go over to the calculator. So I have the square root bracket minus 2 squared. Type exactly what you see and you can't go wrong. It's mistake proof. Another bracket for the minus 2, press equals. So what I get here is a 10. So I'm just going to write that up here in small writing up above the square root sign, a 10. Okay. Now, I'm going to draw two arrows coming out of this, and this is where I kind of wrap it up now, and one arrow is for the minus case and the next arrow is for the plus case. Okay, I'm going to type in now what I'm left with. I don't need that big ugly square root expression anymore. I know that's 10 and I recorded it up there. So what am I left with? On the top I have minus bracket minus 2. Now I'm going to do the minus case first, minus 10. Go down to the bottom and 2 by 12. Again, I know some people will say, should I just type in 24? But if you do this, if there was a minus number there, you might go wrong, and this is mistake proof. What do I get? Minus a third. So the first answer is x equals minus a third. Back to the calculator and do the plus case. Now go over and up, go over up to the top line and change that minus to plus. And what do I get in that case? A half. And see how the calculator gives me a nice fraction answer. Okay. So they are my answers to the big step 1, and they are the stationary points. Okay, so they're the stationary points. If the question asked me find the stationary points, then I would have the question done, because there they are. But I'm afraid it wants me to go further. It wants me to find the local max and min. So again, all we can say, there's one stationary point. There's either a max or a min there, either max min here, and there is either a max or a minimum here. I don't know which is which, and that's my next step. Find out which is which. Okay. So there's either a max or minimum there at that point, minus a third, and there is either a max or minimum point at a half. So there's the big step 2. Classify them. So number 2, find out which is which. So I'll write that anyway. Find out which is which. Now, how did I say I do that again? Find out which is which. How did I say I do that again? I find f dash dash of x and sub each one in. Now again, I just have to scroll up now to find what I had for f dash of x. Now I'm just going to copy it down here because I have a limited space on my whiteboard. So I had f dash of x equals that there. So for f dash dash of x, I differentiate f dash dash. So f dash dash of x equals, again, take the 2 down, but there's a 12 there to meet them, so I'm going to be left with 24. And take 1 off the power, so I would get 1, but I don't usually write power of 1. And for when the power is 1, I'm just left with the number in front. Okay. So my next step, I go through each of the stationary points one by one and sub it into f dash dash. So the first stationary point was minus a third. So I'm going to sub that in to my f dash dash. So f dash dash of minus a third. I don't need to see all the workings. Let's just again get the most out of this calculator, and less writing and more calculator work. Think of that there. The calculator can save time. So what I'm going to do here is, again, over in the calculator video, I explain why I do this. When I need to sub in a number into a function, I use the answer button. It's a safe kind of way to do it. I pretend the answer button just says x, and I type the function in I want into the calculator, and everywhere I see an x, I press the answer button. So I'm going to go 24, pretend it's x, minus 2. Now just press equals. What will come up on the screen doesn't make any sense. Just press equals so that it'll be up in memory. So whenever I clear the screen, it's still up there in the memory. Now, I want to sub in minus a third, so I make minus a third my latest answer, press equals, go up to where you typed in that function there. Where did I type that function in the memory? There it is, 24x, pretend it's x minus 2. So, and as soon as I see it, I can press equals. Now what just happened? It subbed in minus a third into that expression there. And what do I get? Minus 10. Now remember what I said, for the second derivative, I don't care what the answer is when I sub it in. I just want to know if it's positive or negative. So don't even bother writing down minus 10, just say it's negative. And what's my saying? Remember I said negative, sad, frown. Draw your little frown, and that must be a maximum at the top of the frown there. So there is a maximum at minus a third. Okay, now so repeat for the next stationary point. Remember, the next stationary point was the minus a half, or sorry, a half. So repeat all that again. So I have f dash dash of a half. I want to sub that in. Again, if you're stuck, you don't know what I'm at with this memory and the answer button, watch the other calculator video, and I go through it more slowly there. So I want to sub in a half. So make a half your latest answer by typing it in and pressing equals. Go up to the formula you want to sub into. There it appears there, and press equals, and it subs a half into that formula, and I get 10. Again, I don't care what it was, if it was 10, if it was 5, or if it was plus a million. I just want to know if it was positive or negative. So this time it was positive. So write down this positive and draw what your little saying, positive, happy smile. Draw your little smile, and that must be a minimum at the bottom of that smile. So there is a minimum at a half. Now again, all I know at this stage is where the maximum is at and where the minimum is at. I don't know what the maximum is or what the minimum is. How do I find that out? I need to go back to the original function and sub the stationary point in. So let's steal again. I'm going to copy this down. I have limited space in my whiteboard here, so I'm just going to take this down again, the original function. So I have I have f of x equals that there. So there was a max at minus a third. So sub minus a third in to get what the actual maximum is. So f of minus a third. Again, I'm going to use this safe way of subbing a number in, and once you get the hang of it, it'll speed you up a lot. I don't need to see all the workings. I don't need to see you subbing in minus a third. When you write that, it implies that you're about to sub in minus a third into f. I don't need to see it drawn out. Save yourself some time. So again, type the function in, but pretend the answer button is the x button. So 4x cubed minus x squared minus 2x plus 9. Okay, again, what comes up the first time doesn't make any sense. What happened there? Subbed in the last answer I had into that there. Remember I think the last answer was 10. I don't want that there, so just clear all that away. I want to make minus a third my latest answer, so make minus 1 over 3. Now press equals. So go up to the function you want to sub into, and what it will do, it'll sub in minus a third everywhere it sees the answer expression there. So press equals, and it's subbed in minus a third there. Change that, see that button there changes from fraction to decimal. And see them dots there, if you ever wanted to know, that means that sequence starts at repeat, and the number is 9, 407, 407, 407, and if you press that one more time, it shows you that. So that number endlessly repeats 407, 407. Anyway, so I'll just take it as 9.4. I don't need to know all that. So I have 9.4. So that means the maximum is 9.4. And what he doesn't want to know what the maximum is, he wants the actual coordinates. So there, my final little answer is the maximum coordinates are minus a third is the x value, and the 9.4 is the y value. Okay, now repeat one more time for the next stationary point. I know there is a minimum at a half, so I better find out what the minimum is. Find that out by subbing in the half into the original function. So f of a half, again, I don't need to see you writing 4 a half cubed. We know you're about to sub in a half into the function here. So make a half your latest answer by pressing a half equals. Go up to the required formula. As soon as it appears, press equals. What do I get? 8.25. So I'm nearly finished now, because I can write the minimum coordinate is minimum, the x coordinate is a half, and the y value is 8.25. Okay, thank you.